Yo, it's Tada time. Yeah. And today, we're going to be talking about scale figures. Alright, so believe it or not, scale figures are everywhere around us. It's not just something you're going to use in math class. You guys know that game Among Us you guys have been playing? Yeah, of course, red is sus. But what happens there is they actually change the size using scale figures and scale factors that we're going to talk about here in a minute. So think about this. If you were playing Among Us on your phone, well, if I can somehow, drop it to my TV, there's such things. It's got to make it bigger. It's got to scale it. And that's kind of what we're going to be talking about today, is going from like Among Us on your cell phone to Among Us on your TV. So they got to scale it. They have to make it bigger. And so what they have to do is they actually change it by something called a scale factor. All right, so a scale factor is the ratio of any two corresponding links in two similar figures. Now, what's a similar figure? So a similar figure is a figure or a shape that has the same shape but different sizes. So it looks exactly the same, just smaller or bigger. We can think about that. Think about like a figurine, right? Like a Batman figurine. Batman! All right, so the real big Batman, they shrink him down to make a figurine. So that's a scale factor. All right, so it's the ratio of corresponding lengths of two similar figures. All right, so let's look at this example right here. So this example, I have two triangles. Now I can tell if they're similar or not by setting up ratios. All right, so the first thing we want to do is let's pick the biggest length. So in one triangle it's 10, and the other triangle it's 5. So I'll put 10 over 5. And then let's go to the next biggest, 8 over 4, and then 6 over 3. And what you're going to see is if I divided each one of those, I would get the same answer. So that's how I know that these two triangles are similar. So they're the same shape, just a different size. So now, we're going to do a little bit of problems of how to find scale factor and how to use scale factor to find a missing side. Let's go to that right now. Woo! Okay, that's good. All right, so let's look at some examples of how to find the scale factor. So I have these two shapes here. Okay, so I have my original one, it's a smaller one, it's 2 feet. And then I have my new one, which is the larger one, and the side length is 8 feet. Those two sides are corresponding because you'll notice they're on the same side of two similar figures. That's what a corresponding means. It's the same side of two similar figures. So how we find the scale factor is we have to set up a ratio, a proportion, or a fraction. We're going to put the new on top and the original on bottom. So we're going to put what we got to on top and what we started with on bottom. So of course we got to 8, and we're going to divide that by the original, which is 2 feet. So 8 feet divided by 2 feet is of course 4. So what this means in terms of the problem is I had to multiply my smaller or my original one by 4 to get to my larger one. And that makes sense because what times 2 gives me 8? Of course 4. Alright, so let's look at another example. Let's bring in some triangles. So I have my original triangle, which is the larger one in this case. It's got 12 centimeters on bottom. The new triangle has 2 centimeters on bottom. So we're going from bigger to smaller. So in this case, we are reducing. And we're going to talk about why that is here in a minute. So we went from 12 to 2. So I put the new on top and the original on bottom. So I'm going to put 2 on top and 12 on bottom. And when I simplify that fraction, I see that it's 1/6. So what this means is that we multiply 12, or that bigger triangle, by a scale factor of 1/6 to get the smaller one. Now let's talk about scale factors for a minute. So scale factors are different. They either enlarge or reduce. And the number that they are tells us what they do. So for example, if our scale factor is greater than 1. So if it's 2, if it's 100, if it's even 1.1, that's greater than 1. We are enlarging our shape. We're making it bigger. So if you remember from that first example, I went from 2 to 8. That rectangle, I went from the side length of 2 to a side length of 8. We enlarged it, and our answer was 4. That's greater than 1. But what happens if my scale factor is less than 1? So like we just had, the 1/6. Well, we're reducing the shape. We're making it smaller. So in that case, if we have a fraction or a decimal, okay, and it's less than 1, we are reducing the size. So scale factor does matter in that case. So now let's look at an example of what happens if they gave us the scale factor, but wanted us to find the missing side length. Let's look at that right now. Whew. All right, here we go. Let's look at this example here of if I have a missing side length. All right, so I have these two rectangles. The first one they give me, I have a side length of 3 and a side length of 4. And the other one I have a side length of 9, but I'm missing the bottom length. So we know these two are similar. They tell us that. So what we can do is we know that we multiply by the scale factor to go from the first one to the second one. So we can actually set up a proportion. All right, so I'm going to put the first one links over each other. I'm going to put 3 on top and 4.5 on bottom. So where this gets difficult is knowing where to set up the other links. So since I put 3 on top, we need to put the corresponding length on the top on the other one. So that would be 9, because you see they're on the same side of the rectangles. They're both on the right-hand side or left-hand side, depending on how you're looking at it. But from your guys' perspective, they're both on the right-hand side. So because they're on the right-hand side, I'm going to put them together on top. So I'm going to put 9 on top, and then, of course, x on bottom, because that's my bottom length, and that corresponds to the 4.5. So then we cross-multiply. So we'll do 3 times x, 9 times 4.5, and get 40.5 equals 3x. And then we divide by 3, and we see that x equals 13.5. So as you can see, we can use scale factors and similar figures to solve problems with missing side lengths. So now I want you guys to go try this. You guys can rock it. I can't wait to see what you guys come up with, and I can't wait to celebrate those wins of every time you get a problem right. Ta-da time out.